Hello my dear children of class 12 science. Today we will start a new chapter, the last chapter that we do as per reduced syllabus of class 12 from unit number 9. So unit number 9 is electronic devices, and the chapter that we do is completely based on the device only, that is called junction diodes. Okay, junction diode. To start this particular chapter, okay, let me start with a PN junction diode. PN junction diode. The PN junction diode is actually a device. It is a device? It is a device. But what device? A semiconductor device. Semiconductor device. That means this is a device which is made up of semiconductor. But what type of semiconductor? This device is made up of P-type semiconductor and N-type semiconductor. And you know, when I use the word diode, means two. Means by connecting P and N-type semiconductor, okay, in such a manner, so then this device which is formed is called PN junction diode. That's why when P-type semiconductor, okay, is joined with N-type semiconductor, when P-type semiconductor is joined with N-type semiconductor, then the arrangement is also known as P-type junction diode. PN junction diode. So PN junction diode is simply a semiconductor device which is formed by joining P-type semiconductor with N-type semiconductor. Okay, so for that let me just show you the diagram how it will form. So I am drawing the arrangement of this PN junction diode which is formed by joining P-type and N-type. Okay, so let me draw the diagram. So I consider this is a P-type. This is P-type. This is P-type semiconductor. If I join with N-type semiconductor, this is N-type semiconductor. That means P-type semiconductor from P region, where N-type semiconductor from N region. So as soon as when they joined, okay, then the diode, the device which is formed is called PN junction diode. That's why di means connecting with two different parts. Okay. The region where the boundary in which these two P and N type semiconductors are joined is simply called as junction. So this point we simply call as junction. And you know the word junction means the meeting point. So when they are connected by a very thin layer, and this part is called junction. Now children, you know that in P-type semiconductor, holes are the majority charge carrier and electrons are the minority charge carrier. When in N-type semiconductor, electrons are the majority charge carrier and holes are the minority charge carrier. Okay, so as soon as the PN junction diode is formed, okay, there will some diffusion takes place. So diffusion of charge carrier takes place near the junction. So diffusion of charge carrier means hole and electron recombine each other near the junction. Okay, and this hole and electron which recombine at the junction, near the junction, is due to the diffusion of hole and electron. Okay, so that there will be a region which is formed. There will be a small region which is created near the junction, okay, due to the diffusion of electrons and hole near the junction. Okay, and this region which is created is also known as depletion region. What region? Depletion region. Now the word depletion is also called free. The word depletion is also called free. So depletion region, also called layer, also we call. Now the reason why it is formed is because in case of P-type semiconductor, as I said, hole are the majority charge carrier. But this hole which is formed by accepting the electrons, and acceptor atom always has negative charge. So acceptor electron always has negative charge. So when the hole will be created, so remember this children, when there is a hole which is created, there are the atom which always become negative ions. Okay, the atom always become negative ions, and that's why in P-type semiconductor, whenever there is a hole, they are the negative ions, and these negative ions are called acceptor ions. So these are the negative ions. These are called acceptor ions, because these ions can able to accept accept the electrons. Okay, so that there are the holes which is created. Similarly, there is acceptor ions with the holes This acceptor ions with the holes. Similarly, there is acceptor ions with the holes. There is acceptor ion with the holes. There is acceptor ion with the holes. Okay, acceptor ions with the holes. Okay, and even there is acceptor ions like that. So there will be acceptor ions with the hole, acceptor ion with the holes, acceptor ion with the holes. Now remember this. These holes are the what carrier? Majority charge carrier. So in case of p-type, holes are the what? Majority charge carrier. But remember this, they are the electrons also, which are the minority charge carrier in p-type. Okay, but in the region where near the junction, as soon as the p and n-type is formed, this hole, okay, near the junction will diffuse with the electron, okay, at the junction. So that's why in case of n-type semiconductor, electrons are the majority charge carrier, and this electron which is formed by donating the electron, excess electron, and when atom donate the electrons, then that atom become what? Ions. What ions? Positive ions. That's why n-type consists of positive ions. N-type consists of positive ions. These are all positive ions which is formed by creating excess of electrons. There is positive ions creating by excess of what? Electrons. Again, there is positive ions which is created by excess of what? Electrons. So these are all the electrons. These are what? All the electrons. And remember this, in case of n-type, electrons are the majority, whereas hole are also present, but which are minority, very few. Okay, that's why near the junction, electron and hole, this electron and hole, they diffuse each other. From here, electron and hole diffuse each other. Electron and hole also diffuse each other. So when there is a diffusion takes place near the junction of electron and hole, then there is no electron and hole present in the junction. Only the ions will create it. Only the ions will create it. One is negative ions at one end, and there is positive ions at another end. And this region is free from this ion, free from this charge carrier, are called depletion region. We call as what region? Depletion region. And children, you know that this atom, acceptor ions, this is called acceptor ions. Okay, this is called acceptor ions. Is also called donor ions. Donor ions. Okay, they are also called donor atoms. Okay, let me use the word donor atoms. Where, okay, this is donor atom only, not acceptor ion, because acceptor ion is formed by the negative ions in p-type semiconductor, whereas positive ions are the donor ions, or I can simply write as ion. Okay, so remember this, in p-type semiconductor there are the acceptor ions, which is formed due to the majority of the holes, whereas in n-type semiconductor they are the donor ions, which is formed due to the majority of what? Electrons. But as soon as p-n junction diode is formed, there is a diffusion of electrons and hole takes place near the junction, so that there is a region which is created which is free from this electrons and hole, and this region is called depletion region. Depletion means free of charge carrier, but they are the ions which are created at one region, negative ions, and another is positive ions. So a region or layer which is formed due to the diffusion of hole and electrons, okay, near the junction, okay, is also called depletion layer or depletion region. Depletion layer or depletion region. Now you can even see in this depletion region, okay, there are no charge carrier like electrons and hole, okay, but the end where there are only the negative charge, and on the end where there is only the positive charge, okay, which is actually due to what? Losing of electrons and hole in this region, okay, but this negative and positive charge acquire within the depletion region created a potential difference, okay, between the region, and this potential difference, okay, is also known as potential barrier. We also known as what? Potential barrier. So this region which is created is also known as potential barrier. Potential barrier. And this potential barrier is measured by the voltage, and this voltage is given by BB, and this BB is also called barrier voltage. We also call as what? Barrier voltage. We can also call as barrier voltage, okay, also called potential barrier, okay. Now under this case, if any holes that has to move from p type to n type, or any electron has to move from n type to p type, they have to actually get a voltage that is equals to how much voltage? Barrier voltage. Otherwise the holes from p type cannot cross to the n type, or electron from n type cannot cross to the p type. Okay, that's why as soon as the p-n junction is tied, okay, barrier voltage is always maintained. Okay, and this barrier voltage is also known as potential barrier. Okay, and both this barrier voltage and potential barrier depend upon the type of semiconductor which is formed. Like if p-n junction diode is formed of silicon, if p-n junction diode is formed of germanium, then they have different barrier voltage. That means the barrier voltage or potential barrier in which the p-n junction diode is made up of silicon or germanium are not same. Therefore, this device and this arrangement which is formed by connecting p-type and n-type semiconductor is also known as p-n junction diode. Now there is a symbolic form of p-n junction diode. So we can represent this p-n junction diode in symbolic form also. And this is the symbolic form of p-n junction diode. This is P, the triangle with arrowhead is called P, and this leg terminal part is called n-type. So this is the symbol even that we use for p-n junction diode. So p-n junction diode can be represented symbolically in the circuit diagram, okay, especially in the circuit diagram, and is represented by this symbol. So this is the symbol of what diode? p-n junction diode. p-n junction what? Diode. Now let me just write the value of this potential barrier or barrier voltage, and this is almost approximately 0.3 volt if we take the p-n junction diode made of what? Germanium, and the value of this barrier voltage or potential barrier will be 0.7 volt if this p-n junction diode is made up of semiconductor like silicon. Okay, that means these are the barrier voltage or potential barrier for germanium and silicon. Now as soon as this barrier voltage is generated or potential difference is maintained, there will be a field, electric field set up within the p-n junction diode also, and this electric field is called internal electric field. And internal electric field always set up from positive plate to negative plate. So I am showing with the help of diagram EI. So in the diagram you see EI is the internal what? Internal electric field. Electric field set up, okay, due to what voltage? Due to what barrier? Potential barrier. Due to potential barrier or barrier, sorry, this is barrier. Due to potential barrier or barrier voltage, the internal electric field is set up that is always directed from positive plate to negative plate, because you know that electric field is always directed from positive charge to negative charge. That's why the internal electric field set up, which is EI, is direct from positive plate to negative plate. And this electric field helps the minority charge carrier, like in case of n-type, minority charge carrier holes, and in case of p-type, minority charge carrier electrons, to move in, to cross this barrier, barrier. And the region on both sides of this junction, you can see, which has become depleted or free from the mobile charge carrier, no holes and electron, okay, which has already diffused in the region, are called depletion region. And the width of the depletion region, let me just tell you children, this width of the depletion region is almost 10 to minus 6 meter, very small width. The width of the depletion region, which is formed by connecting p and n-type semiconductor, and due to the diffusion is nearly how much? 10 to minus 6 meter. So this is the detailed explanation of the basic part of this p-n junction diode which is formed. Now in the next YouTube video you basically learn biasing of p-n junction diode, and this biasing are nothing but forward biasing and reverse biasing.